In this lesson, we'll do an additional example on solving exponential equations. Here, we're asked to solve the exponential equation 9 to the x is equal to 7 times 3 to the x plus 18. In the previous exponential equations that we've solved, our goal has been to express both sides of the equation using a common base. Here we have several different terms, some of which have a variable in the exponent and some of which do not. So we're not going to be able to apply exactly the same techniques, but we'll keep in mind that previously we've been able to solve exponential equations by expressing all of our terms using a common base. So the first thing that we'll do in this exponential equation, let's move all of our terms to the left-hand side. So this gives us 9 to the x minus 7 times 3 to the x minus 18 is equal to 0. And again, keeping in mind this technique that we've looked at previously of expressing terms using a common base, we see that one of our terms with a variable in the exponent is this 7 times 3 to the x term. We also have this 9 to the x term, and we notice that 9 can be expressed as 3 squared, so that 9 to the x is the same thing as 3 squared all to the x. So let's go ahead and rewrite 9 as 3 squared, and our equation then becomes 3 squared to the x minus 7 times 3 to the x minus 18 equals 0. This gives us, using our rules of exponents, 3 to the 2x minus 7 times 3 to the x minus 18 is equal to 0. And now again, using our rules of exponents, 3 to the 2x is the same thing as 3 to the x all squared minus 7 times 3 to the x minus 18 equals 0. So again, we've used our rules of exponents. These exponents multiply, so we have that 3 squared to the x is the same thing as 3 to the 2x, which is the same thing as 3 to the x all squared. And now this equation that we have here, this is an equation that is quadratic in form. So it's not exactly a quadratic equation, but for example, if we were to make the substitution y equals 3 to the x, then this would become y squared minus 7y minus 18 is equal to 0. And notice that this equation factors as y minus 9 times y plus 2 equals 0. So using that idea, we can take our equation 3 to the x all squared minus 7 times 3 to the x minus 18 equals 0, and we can factor this equation as 3 to the x minus 9 times 3 to the x plus 2 is equal to 0. And again, at this point, you should just multiply this out and check that this equation really is the factored form of the equation in the previous line. So now using our zero factor property, we get that 3 to the x is equal to 9, or 3 to the x is equal to negative 2. Remember, that comes again from the zero factor property. We have that 3 to the x minus 9 equals 0, or 3 to the x plus 2 is equal to 0, which gives us 3 to the x equals 9, or negative 2. Now, 3 to the x, 3 to any power is always positive, so we can't have 3 to the x equals negative 2. So there are no real solutions of 3 to the x equals negative 2. So we get that 3 to the x is equal to 9, which gives us that x, 9 is 3 squared. So using our property, we have the same bases now. 3 to the x equals 3 squared. So this gives us that x is equal to 2. So we have the same base, so we can equate the exponents to get that x is equal to 2. And of course, we can check this by taking our x equals 2 and just plug it back into our original exponential equation and make sure that our given equation is satisfied.